Okay, so my name is Bilal, and today we'll be solving additional mathematics session Feb March year 2022, paper 1, variant 1 2, and the subject code is 0606, which is of 2 hours. Now, before starting, I would like to make an announcement, that is, please do like, share, and subscribe our channel. Now, question 1 is given as find the values of k such that this equation, this line, does not meet the curve y is equals to this curve's equation. The when does not meet the curve is given, so this is basically b squared minus 4ac. Our discriminant is basically lesser than 0. So we can substitute this 9kx plus 1 over here. Then we will get it as, and we will be multiplying 3 by this and then this again. So this would be 9kx plus 1 equals to kx squared plus 6k plus 3 multiplied by x and then plus 4. Then we'll rearrange it and bring all these things on the right hand side. So this would be written as kx squared. This 9k would be added here, so this would be subtracted here. So this would be 3 minus 3k. 6 minus 9k is basically minus 3k, and this would be x, and then 4 would be subtracted. 1 will be subtracted from 4. This would give us as plus 3. So we have our b as this, our a as this, and our c as this. So we can write this as a as k, our b is 3 minus 3k, and our c is 3. Now let's substitute it in this equation. This would be 3 minus 3k whole squared minus 4 into k into 3, which is lesser than 0. So we get the answer as 3 squared is 9, 3 into 3 is 9, 9 into 2 is 18, so this would be minus 18k, and then 3k squared is basically 9k square, and this would be minus 12k lesser than 0. So this would be finally written as 9k squared negative 30k positive 9 is lesser than 0. We can divide it by whole equation by 3. So we'll get our answer as 3k squared negative 10k positive 3 is lesser than 0. Now we can use the calculator and get our answer. We'll get our answer as 3k minus 1 and k minus 3, which is lesser than 0. So we'll get our answer as k is equals to 3 and k is equals to 1 over 3. So since it was lesser than 0, let's recap. So this was basically the curve, and it has to be lesser than 0. So we need these values, and these values could be found in, this is 1 over 3 and this is 3. These are 0 at this. So this is 1 over 3 till 3. So we'll write our final answer as the k lies between 1 over 3 and 3. So we can write our answer finally as this. So this was our first question. Now let's move to the question number 2, which is solve the equation 3 minus 5 root 3 x squared plus 2 root 3 plus 5. Now it's a similar question, giving you a solution in the form this, where a and b are the rational numbers. Now here we need to use the quadratic formula. So let's use the quadratic formula here. And one thing more is given, we don't have to use the calculator. So our quadratic formula is given as negative b plus minus b squared minus 4ac, that is our discriminant, over 2a. Our a is basically 3 minus 5 root 3, which is the coefficient of x square. Our b is 2 root 3 plus 5, and our c is negative 1. So this could be written as negative 2 root 3 negative 5. This is basically multiplied by negative, and then positive negative root would be 2 root 3 plus 5 whole squared, negative 4 negative 1, and then 3 minus 5 root 3 over our 2a, that is 2 into 3 minus 5 root 3. So this is our quadratic formula substitution. Now let's solve this first. We'll be solving this by solving this part first. So this would be negative 2 root 3 as it is. 2 root 3 negative 5 positive and negative. Then we can simplify it by solving this first. So this would be 2 root 3 whole squared would be 12. 2 squared is 4 and root 3 squared is 3. So this would be 12. And then 2 multiplied by 2 root 3 and then 5. 2 multiplied by 2 is 4. 4 multiplied by 5 is 20. So this would be 20 root 3. And then this would be 5 squared. This would be 25. This would be positive 4. And positive 4 will be multiplied by 3. That is 12. And then positive 4 would be multiplied by negative 5 root 3. So this would be negative 20 root 3. This 20 root 3 and this 20 root 3 would be cancelled out. This we are given as 2 into 3 minus 5 root 3. Now let's solve these. So we'll get our answer as 25 plus 24 is 49 and 49 square root is 7. So we get it as 2 negative 2 root 3 negative 5 plus minus 7 over 2 3 minus 5 root 3. Let's solve this first. We'll be solving it individually. The positive will be solved individually and negative will be solved. Now if we take it as negative, so this would be negative 5 and negative 7 will give us as negative 12. And then here we have 2 3 minus 5 root 3. This we can take 2 as common from the numerator, and then we will get our answer as negative 3 negative 6 and then 3 minus 5 root 3. Then we can solve the positive part. Our positive part would look like negative 2 root 3. Negative 5 plus 7 would be basically 2, positive 2. And then we can take 2 as common to get our answer as finally negative root 3 plus 1 over 3 minus 5 root 3. Now, denominator must not have a rational number. So we need to remove it. We'll remove it by multiplying it by the conjugate. So this would be 3 plus 5 root 3. Then we'll be multiplying it by the numerator as well. We'll do the same here as well. So after multiplying, we'll get the answer as our numerator would be 3 squared is basically 9 and 5 squared is 25. 25 multiplied by 3 is 75. So this would be 9 minus 75. This would be negative 66. And then this would be multiplied. So this would be negative 3 root 3. Negative 30 root 3. Negative 15 and negative 18. So we will get our final answer as this would be negative 33 and this would be negative 33. This would be cancelled out by 66. So we'll get our final answer as 1 over 2 root 3 plus 1 over 2. Since this negative and negative would be cancelled out. Now solving this part. So this would be negative 66 again. And numerator part would be negative 3 root 3 and 5 root 3, positive 5 root 3 and positive 3 and negative 15. So we'll get our final answer as negative 2 root 3 over here and positive 12. So we need to cancel this out. So this would be negative 1 over 33 root 3 and plus 2 over 11. That would be simple. That would be 12 over 66 can be cancelled out by getting our answer as this. You can cancel out by simply cutting 6, dividing both by 6. So this would be 2 and 11. So these are our final answers. Now moving on to question 3. We have the curve with equation y is equals to a sine bx plus c, where a, b and c are constants, passes through the points 4 pi, 11 and negative 4 pi over 3, 5. It is given that a sine bx plus c has period of 16 pi. Find the exact values of a, b and c. Now, since has a period of 16 pi. This means we can simply calculate the normal has a period of 2 pi, and we can divide it by 16 pi. So we'll get our answer as 1 over 8. Our B is simply 1 over 8. Now we need to calculate A and C. So we'll be solving this by plugging in all the values. This would be 11, this value, and then sine 1 over 8 multiplied by 4 pi plus C. We'll be using two quadratic equation, two simultaneous equation to solve A and C. And then we'll be plugging in this. This would be A sine 1 over 8 negative 4 pi over 3. So this would be 1 over 2. So this would be pi by 6, negative pi by 6 plus C. We can multiply it by negative 1. So we get it as the above equation is 11 equals to A. This is basically pi by 2. Pi by 2 is 1. So this would be A plus C. Below equation would be 5, and then this would be negative 1 over 2. So this would be negative A over 2 plus C. You can multiply whole equation by negative. So this C will be cancelled out, and we'll get our answer as 6 equals to 3A plus 3A over 2. This 2 would be multiplied and 3 would be divided, and A will get our A as 4. And we can plug in this equation, so we'll get our C as basically 7. So these are our answers. Now moving on to part B, we have using your answers to part A, find the coordinates of the minimum point on the curve for 0 till 16 pi. We need the maximum and the minimum point. Sorry, only the minimum point. So we have our A as 4. So this would be 4, sine B as 1 over 8. So this would be 1 over 8x. And then our C as 7. So this is our equation. Now, since we need to get the minimum point, what we need to do is we need to assume that this is basically negative 1, because sine's least value is negative 1. So this would be negative 4 and positive 7. We'll get our final answer as 3. Alright. So we'll have our maximum value at 4 pi, and our minimum value or zeroth value would be at the curve will have the minimum value at 8 pi. 0 at 8 pi, it would be 0 at 8 pi, and 12 pi will have the minimum value. 8 pi will have 0. Since we can plug in over here, so this would be pi, and sine pi is 0, and this would be 7 basically. We can write it as 7 as well. 8 pi would be 7. So for the minimum value, we can plug in over here 12 pi. This would be 4 sine 1 over 8, 12 pi plus 7. So this would be 2, 4 3s are, and then 2s are. This would be 3 pi by 2. 3 pi by 2 is negative 1. So this would be negative 3. So this would be simply 12 pi positive 3, sorry. And then our y as 12 pi by 3. So these are our coordinates, final answer. So this is our final answer. Moving on to question 4, we have show that this can be written as this. This is a pretty simple question. We need to multiply simply 2x minus 1 over here and in the denominator as well. So this would be 2x minus 1 whole squared. This would be 2x minus 1 plus 4 would be 2x plus 3. This was a pretty simple question. Moving on to part B, we have find this, giving your answer in the form a plus ln b. Now this looks similar to this. We'll be using these parts. So this can be written as 5 to 1 over 2x minus 1 plus 4 2x minus 1 whole square. We can take this above. So this would be written as 5 to 1 over 2x minus 1 plus 4 2x minus 1 power minus 2. Now we can solve this. So this would be, we need to have 2 over here. So we'll be multiplying by 2 and dividing by 2. So 2 gets over here and then 2 is over here. This would be 1 over 2 ln this function 2x minus 1. This would be integrated by adding one power. So this would be negative 1, and this negative 1 would be multiplied. So this would be negative 4, and then power would be reduced. So this would be 2x minus 1 power 1, and then this differentiation would be multiplied. So this would be simply this. We have our integration. We can substitute our limits. So this would be finally written as 1 over 2 ln 2 5s are 10, minus 1 is ln 9. This would be ln 9, and then this would be 2 over 9. So this would be negative 2 over 9. This is our upper limit minus our lower limit. Our lower limit would be 2 into 2 is 4, 4 minus 1 is 3. So this would be ln 3, negative 2 over 3. So this can be written as, this can go over here. So this would be ln 3 minus 1 over 2 ln 3, and then minus 2 over 9 positive 2 over 3. This can be multiplied by 3. So we'll get our final answer as ln. Since this is root 3 and then root 3 is cancelled out by 3, so this would be finally written as ln root 3 plus 4 over 9. So this would be 6. 6 minus 2 is 4, and then this is 9. And this has power 1, and this is basically power 1 over 2. So this will go, the subtraction, this will be subtracted, and we'll get our final answer as this. So we'll have our final answer as this, since it was written like this. Now moving on, we have our question 5 as variables x and y are such that y is equals to this, find dy by dx. Now we have to apply the quotient law. Quotient law, I'll be writing quotient law over here. So this would be d over dx. When the two functions are divided, that are u and v, we can write this as u and this as v. So it is written as v u dash minus u v dash, where dash represents the differentiation of the function, and then we can write it as 3x. Since this is v, 3x, our u is ln 2x squared minus 3. We have to differentiate it. A differentiation would be, the differentiation of the function comes in the numerator, so this would be 4x, over the function comes in the denominator, 2x squared negative 3. Then this would be ln as it is, and then v dash would be multiplied, so this would be the 3. Then we have our denominator as 3x whole square. We can leave it over here, since it's a small question and a small marks, lesser marks. It contains lesser marks. So moving on to part B, hence find the approximate change in y when x increases from 2 to 2 plus h, where h is small. Now we are given with this question, where x increases from 2 to 2 plus h. Now since we have lesser space over here, so we'll be utilizing the space effectively. So this would be x equals to 2. It moves to 2 plus h. So the delta x would be h. Now when x equals to 2, we have to plug in this x equals to 2 over here. So we get our answer as dy by dx as, this can be multiplied and this can be multiplied. I'm writing the answer directly. So this would be 12 2 squared, then 2 into 2 squared minus 3 ln 2 into 2 squared minus 3 upon 9 into 2 square. So this would be 48 over 5 minus ln 125, and then 36. So you get this as 0.1325. So we have our dy by dx. This can be written as delta y. Delta x is written as is equals to dy by dx. So we have our dx as h, and our delta y would be 0.1325 h. So this would be our final answer. Now moving on, we have our part C as at the instant when x equals to 2, y is increasing at the rate of 4 units per second. Find the corresponding rate of increase in x. So when x equals to 2, we have our dy by dx as 0.1325. This we have calculated in the previous part. So the chain rule can be written as dy by dx, dy by dt divided by dx by dt. So we have y is increasing at the rate of 4 units per second. We have dy by dt as 4, and we have our dy by dx. So we can simply solve this. Our dx by dt would be dy by dt upon dy by dx. So this can be written as 4 over 0.1325, and then by calculating we get our answer as 30.18, which equates to 30.2 approximately. So this is our final answer. Now moving on to question 6, we have the normal to the curve y is equals to 1 plus tan 3x at the point P with coordinates x coordinate pi by 12 meet the x-axis at the point Q. The line x equals to pi by 12 meets the x-axis at point R. Find the area of the triangle PQR. So we have the normal to the curve at point P where x coordinate is pi by 12. We can calculate the y coordinate as well by plugging in pi by 12 over here. So this would be 1 plus tan 3 and then pi by 12. So this would be pi by 4. Pi by 4 is basically 1. So this would be 2. So when x equals to 3, x equals to pi by 12, y equals to 2. So this can be written as pi by 12 and then 2. This is our P point. Now for Q point, we need to calculate the normal and which meets the x-axis at point Q. So for that we need to first calculate the differentiation of this equation of this function. This would be dy by dx would be 3 6 square 3x. So this would be our simply differentiation. We have our x as 2. So this would be 3 over cos squared 3, then pi by 12. Our x is pi by 12, sorry. Confusing it by y every time. So this would be pi by 4 and our gradient would be 6. Now our normal's gradient would be negative 1 over 6 since it's the negative reciprocal of that, and our final equation can be written as y is equals to negative 1 over 6x plus c. We have this coordinate we can plug in over here. So this would be 2 equals to negative 1 over 6 multiplied by pi by 12 plus c, and then this would be 2 plus pi by 72 equals to our c. So since it meets the x-axis at point Q, x-axis would be y equals to 0. So we can write this as y is equals to negative 1 over 6x plus 2 plus pi by 72. X-axis y equals to 0. So we get our answer as 1 over 6x. This 1 over 6x would go over there since it's 0. And then this would be 2 plus pi by 72. This 6 would be multiplied, and then we'll get our answer as 12 by plus pi by 6 as our x. So our q can be written as 12 plus pi by 6 comma 0, and we have our r as meets the x-axis. The line x equals to pi by 12 meets the x-axis at point r. Since it's a pi by 12 line, so this would be r can be written simply as r pi by 12 and then 0. Now we need to calculate the area of the triangle. It's a pretty simple task. We can do what we can do is just illustrate it first. This can be drawn as this is pi by 12 and then 2. Let's just assume everything. So this would be pi by 12 and 0. So let's say this is pi by 12, and then this 12 pi plus pi by 6, and this is this, and then we have pi by 12 as, which is something above r. This would be something like this. So we have our triangle like this. So this would be our height and this would be our base. So our height is basically this same, right? So this PR is basically 2. So this would be 1 upon 2 multiplied by 2, and our base is QR. So this would be this subtracted by this. So this would be 12 plus pi by 6 negative pi by 12. This would be cancelled out and we'll get our final answer as this. So this would be 12.26 approximately. So this is our final answer. Now moving on to question 7. We have a curve y is equals to f of x is such that d square y dx square is equals to this. The curve passes through the point this. The gradient is given and we need to find the original equation. So we need to find the original equation. We are given with d square y dx squared, which is given as 2 minus 3x powered negative 1 over 3. We need to integrate it to further solve it. Now we need, if we integrate it, then we get our answer as dy by dx, which is basically this power would be added. So this would be 2 power 2 upon 3, and then this would be 2 minus 3x. This 2 upon 3 would go in the denominator, so this would be 3 upon 2, and then this would be multiplied by the denominator. So this would be simply written as negative 2 minus 3x power 2 upon 3 over 2 plus c, and we have our gradient as negative 6 and our x as negative 2. We have to plug in x as negative 2 over here. So this would be written as negative 6 negative 2 minus 3x 2 minus, this would be minus 3, and then minus 2 would be plus 6 power 2 upon 3 plus c, and then 2. This would be 8, and 8 is basically 2 power 3. So this would be cancelled out. This would be 4, and minus 6 minus 4 over 2. This would be cancelled out. So this would be simply written as negative 4. This would go over there. So c would be negative 4. So we can write our dy by dx as, our dy by dx will be simply written as negative 2 minus 3x powered 2 over 3, then negative 4 as our c, and we have 2 as our denominator. Now we need to integrate it again to find the actual equation. So we have our actual equation as y is equals to, this would be integrated, we will get a final answer as, let's just simply move this one over to out, and this would be negative 2 negative 3x. This would be 5 over 3, and then this 5 over 3 would go in the denominator. We can write this as 3 and then 5, and then this negative 3 would be multiplied again. This negative 3 and this negative 3 would be cancelled out. So, and then here we have as negative 4x, then plus c. So we get our final result as 1 over 10, then 2 negative 3x powered 5 over 3, negative 4x plus c as our y. We can plug in these points, that is negative 2 and then 10.2 to get our final equation. So this would be 10.2, 1 over 10. This would again be 2. Minus 3 minus 2, this would be 5.3, this would be, and then this would be plus 8, I guess, yes, plus 8. So this is basically 8, and then 8 is basically again 2 power 3, so this would be cancelled out, so this would be 32, and then 32 divided by 10 is 3.2, so this would be 10.2, 3.2 plus 8 plus c, this whole would be added, so you get our answer as 11.2, I guess, and then this would be subtracted over here, so we'll get our c as negative 1. Now we are writing our final equation. Our final equation can be written as y is equals to 1 over 10, 2 minus 3x powered 5 over 3, negative 4x, negative 1 as our c. So this is our final f of x, or the equation. Now moving on to question 8, we have in this question all lengths are in meters and all times are in seconds. A particle A is moving in the direction negative 20 and 20 with a speed of 58. Now we have the speed of 58. Let's just calculate the magnitude of this. This would be 20 squared, then 21 squared. We get our answer as 29, but the speed is 58. Since the speed is 58, we need to divide it by 29, so this would be 2. And then we can calculate the velocity vector. We need to multiply it by 2 ways simply. This would be negative 40 and 41. 42, sorry. This is our final answer. Given that A is initially at the point with position vector 5 minus 3, write down the position vector of A at time t. It needs a position vector of A at time t. So this is pretty simple. So this is, it has a position vector of 5 minus root 3. Initial is 5 minus root 3, and it is moving in the direction for minus 40 and 42 t. So this is basically simply our answer. A particle B starts to move such that its position vector at time t is this. Find the displacement vector AB at time t. So AB can be written as OB minus OA. We have our OB here. So this is basically negative 35t plus 4, 44t, negative 2. Our OA was simply here. We will be just replacing it here. So this would be 5 minus 40t, then negative 3 plus 42t. Then we'll be calculating all of this. So we'll get our answer as 5t minus 1 and then 2t plus 1. So this is our AB's vector. Now we need the displacement vector. So for displacement we need to calculate the magnitude. The magnitude will be calculated by 5t minus 1 whole squared plus 2t plus 1 whole squared. So this would give us our answer as 25t square plus 4t square with this, and then we have our negative 10t here, and then here we have negative 4t, then positive 1 and positive 1 again. So we get our answer as 29t squared minus 6t plus 2, and sorry, made a mistake over here. So this was the next part, I guess. So this is our final answer over here. Now moving on to part D, here we need to find the distance at time t. It was simply given as displacement vector, I'm sorry. Now hence find the distance AB at time t in the form of this, where PQR are constants. So we need the distance. For distance we need to calculate the magnitude. So this would be, I'll be quickly solving it since we have solved it previously. So this would be 25t squared, 4t squared, then negative 10t, then positive 4t plus 1 plus 1. So this would be 29t squared, negative 6t, and then positive 2. This is negative 6 and this is 29 and this is 2. So we have our answer in this form. Moving on to part E, we have find the value of t when the distance AB is root 6, giving your answer to this. So we have our distance as root 6, and then this 29t squared, negative 6t, positive 2, this would be cancelled out. So we get our answer, we get our final equation as negative 6, 29t squared, negative 6t. This would go over there, so this would be negative 4. we can use the calculator over here. So we'll get our final answer as t is equals to 0.49. And if we get our negative answer will be ignored since t is always positive. Now moving on, we have our question 9, where the a part is given as the function f is such that f of x ln 5x plus 2 for x is greater than a, where a is as small as possible. Write down the value of a. So for that we need to calculate the value of when this is 0. So this would be 5x minus 2 equals to 0. So this x would be negative 0.4. X needs to be greater than 0.4, negative 0.4. So this is basic our a. Hence find the range of f. The range of f will be simply r all the real numbers, since it can be anything. Hence find f of inverse of x, stating its domain. Now the domain is needed. Its domain would be simply as the range. So this would be x belongs to real numbers. Let's calculate the inverse. So this would be this, and then e powered y is equals to 5x plus 2, e powered y negative 2. This 5 would be divided, so this would be x. We can write this as f of inverse of x as e powered x negative 2 over 5. So this is our final answer. Now on the axis, sketch the graph of y is equals to f of x, y is equals to f of inverse of x, stating the exact values of the intercepts of the curve and the coordinate axis. I can just simply do one thing, that I can calculate the asymptotes and each and everything first. So this would be x equals to 0 in our f of x. When we keep x equals to 0, so we get our answer as y is equals to ln 2. This would be 0 and this would be ln 2 simply. So, and we have our asymptote at x equals to negative 0.4, since it can't go below this. Alright. So next, for f of inverse of x, sorry, we can do one more thing for f of x, which is we can write it as y is equals to 0. If we assume y is equals to 0, we have our x as negative 0.2 by using the calculator. Now for f of inverse of x, let's just write it over here. So this would be f of inverse of x. These would be simply switched. So our x would be ln 2, our y would be 0, asymptote at y equals to negative 0.4, and our x would be 0 and y equal to negative 0.2. You can draw it by yourself and I can do it as well. So this would be x equals to 0 when ln 2, y is equals to ln 2. So let's suppose this is ln 2. So this is our point. We have an asymptote at x equals to negative 0.4. So this, let's assume this is 0. Negative 0.4. And we have our y0 as x equals to negative 0.2. So this is basically it. This would be our graph. And for this, we can do what we can do is calculate the negative 0.4 our asymptote or as our asymptote. So this would be, I guess, something above this. Let's just assume this. So this would be our asymptote, and our x is ln 2. So this would be ln 2. Let's suppose this is ln 2. Our y would be 0 over here. And our x would be 0 and y is equals to negative 0.2. So let's just assume this is 0.2, negative 0.2. So this would be drawn as something like, let's just use the different pen. This would be this. So this would be something like this. So this was our question. You can simply draw it. I would prefer you draw it by your own self because each and everything is given now. Now moving on, we have our part B as the function g is such that g of x is x of powered 1 over 2 minus 4 for x is greater than 0. Solve the equation g squared x is equals to negative 2. So we need to include g of x in its own function. So this would be g of squared x would be, this would be included in itself. So this would be x powered 1 over 2 minus 4 powered 1 over 2 minus 4. This is equals to negative 2. This 4 will go over there. So this would be 2 x powered 1 over 2 negative 4 powered 1 over 2. To remove this powered 1 over 2, we can simply square it. So this would be 4 x powered 1 over 2 negative 4. This 4 would be going over there. So this would be powered. So this would be 8. We get our answer as this. Then we can just simply remove it by squaring it. We get our x as 64 basically. This was our answer. Now moving on to question 10. Part A, we have the first three terms of arithmetic progression as this. Find the exact values of x where x lies between 0 till pi by 2 for which the sum of 20 terms is equal to 390. Since it's an arithmetic progression, we need to calculate the common difference, which can be written as t2 minus t1. We have 5 sine 3x minus sine 3x. So this is basically 4 sine 3x as our common difference. We are given with the sum of 20 terms. So sum of 20 terms can be written as 20 over 2. 2a is basically sine 3x plus n minus 1 is 19. 20 minus 1 would be 19 and our common difference is 4 sine 3x. So let's just take 2 as common and cancel it. Wait, what we can do is cancel 2 by this. So this would be 10 and then cancel 390. This is 390 by this. So we get our answer as 39 and then 2 sine 3x. Then 19 into 4 is 76 sine 3x. So what we can do is just simply divide 78 by this 39. So this would be 39 divided by 78 as our sine 3x. We get it as 1 over 2. Sine inverse 1 over 2 is basically pi by 6. So we'll be getting our answer in the first and the second quadrant. So this would be pi by 6. Then 5 pi by 6, since this pi by 6 would be subtracted by pi. This would be 5 pi by 6 equals to 3x. This 3 would be divided. We get our answer as pi by 18 and 5 pi by 18 as our x. So this is our final answer. Now moving on, we have our part B as the first three terms of a geometric progression. Now we have been given with the geometric progression. The first three terms of a geometric progression are 20 cos y, 10 cos square y and 5 cos cube y. We need to calculate the r. So let's calculate r. R would be t2 upon t1. Term 2 upon term 1. So this is our term 2 and this is our term 1. This would be cancelled out. This would be 0.5 and this would be cancelled. So this would be 0.5 cos y as our r. Now cos has a maximum value of positive 1 and a minimum value of negative 1. So this would be positive 0.5 till negative 0.5. Now since magnitude of r is lesser than 1, it's a diverging progression. So it has a sum to infinity. Now moving on to part B, part 2, that is find the value of y where y is in radians. For y should be in between 0 till 2 for which the sum of infinity is 9, giving your answer correct to 2 decimal places. So our sum to infinity can be written as a over 1 minus r. Our sum to infinity is 9. Our a is basically 20 cos y as per above this. Our R is basically this. This is 1 minus 0.5 cos y. This will be multiplied over here. So this would be 9 minus 4.5 cos y. And then 20 cos y. This will go over there. So this would be 9, 24.5 cos y. This would be divided. So this would be 9 over 24.5. And then cos inverse, since it's positive. So this would be in the first and the last quadrant. Last quadrant can't be held because this is between 0 till 2 and it is in radians. So this would be simply be in the first quadrant. We calculate this, we get our answer as 1.19. So this is our final answer. Now thank you for watching. This was it from my side. Please do like, share and subscribe.